All right, so good evening. Just going to give my thoughts and opinions on the severe weather setup tomorrow. As always, these views and opinions are my own. They do not reflect those of my employer, the Weather Service, or the Storm Prediction Center. These are solely my opinions. Second, if you don't already have a plan in place for severe weather, make sure you do. Get that sorted out. You are running out of time, so make sure you do have a plan in place. And lastly, just please stay tuned and keep updated with the National Weather Service, your local forecast office, as well as the Storm Prediction Center and their updates. A lot of talented scientists, meteorologists. They're the best in the business when it comes to forecasting, watches, warnings, things like that. So really, your primary resource should be the Storm Prediction Center as well as the National Weather Service. So with that being said, just like to get started. So really, these are just my thoughts and opinions on tomorrow's setup. So as you can see across the central and southern Great Plains this evening, really just a well-established warm front located across central Texas. You can see to the north of the front, winds are mainly out of the east or northeast. Moisture is a little bit lower, but to the south of the front, kind of just over south of Austin to kind of Houston, I guess Huntsville, Texas, that kind of line right there. Winds are flowing in right off the Gulf. A lot of very warm, moist, rich air. Dew points are in the mid to upper 70s, even low 80s in around Corpus Christi. So just a very juicy, unstable maritime tropical air mass, just fully modified maritime air off the Gulf and Caribbean. So just extremely juicy and unstable air mass south of the front there. As the upper level wave eventually ejects off to the north and east, this stationary front as a response should lift to the north, and it will kind of establish itself somewhere in the vicinity of north central Oklahoma, but ultimately where this what will be a stationary front, where it stalls out, this will probably be a concentration for supercells and just training convection. I think flooding is going to be a really big concern here, especially across much of Oklahoma, much of the western half of Oklahoma. Also, not terribly well established at this time, but there is a dry line that will become a lot more well established tomorrow across West Texas, somewhere in the vicinity of Lubbock, Amarillo, somewhere out there, the western Texas Panhandle. Um, so really, just a lot of moving parts into tomorrow. But let's just talk a little bit about just the synoptic features. But before that, let's get into um, the just observed soundings. So this is Corpus Christi this evening. So we're located to the south of that warm front. You can see just a very unstable air mass. Surface dew point here 80 degrees Fahrenheit, so it's extremely moist. So this is really that moisture component that we need for severe thunderstorms into tomorrow across central Oklahoma. Just a lot of instability as well. That's yeah, 3,300 joules per kilogram of mixed layer CAPE. So that's just ridiculous, especially at 0Z. That's crazy. Um, Brownsville, same thing, just to the south, just ridiculously high surface moisture, dew points in the upper 70s there, as well as large buoyancy. Norman, we're pretty quiet this time. We're located to the north of the front, well to the north of the front. So pretty dry. Winds are out of the east northeast. Starting to get a little bit of instability as we're bringing some of those steeper lapse rates off the higher terrain from the west. A little bit of buoyancy located below 500 millibars, kind of in that 500 to 700 millibar layer. But again, this thermodynamically, this will change very rapidly tomorrow morning as that front surges northward. Um, so this is GO16 mid-level water vapor imagery. You can see the cyclone. This is located in the mid-levels, centered somewhere over Nevada, kind of the Great Basin area, maybe moving to parts of Arizona. But this will again eject off to the north and east. And as a response to that, we will see strengthening, not only mid-level flow, but low-level flow as well. Some of the 850 millibar charts for tomorrow from some of the models are just, it's insane. I haven't seen anything like it in my few years of weather nerding out and stuff. But really, just a strongly synoptically forced system, warm front, dry line. These are all going to be ingredients that are going to be coming together for lift in terms of severe weather. This is just basically what I'm showing on water vapor imagery, except we're looking a little bit above that level now. This is really the jet stream level, 300 millibars, and you can just see this. I guess that's just a jet stream kind of rounding the base of the trough. It's going to start to dig a little bit to the south and east. I believe that's 110, 105 knots. So that's very strong for this time of year, especially as we're moving into the warm season, into the summer. Lack of a horizontal temperature gradient usually implies weaker flow aloft. But this is just a very, very strong synoptic system that will eventually move off to the north and east. And just looking at things like Cape, especially over Texas, I mean, it's 3Z at this point, so we're well past sunset. I mean, you still have 4,000 to 3,000 joules per kilogram of mixed layer Cape to the south of the front. So just a very unstable air mass, and that will all be coming in place over central Oklahoma tomorrow. So this is just kind of the evolution, just going to kind of dive into models. So as you can see, that wave eventually will eject off. Really, the strongest vorticity advection looks to be a little bit actually to the north, kind of northwestern Oklahoma. So maybe not the strongest synoptic forcing exactly over the risk area. Again, you'd want to look at the vorticity advection, how that changes over a layer to diagnose sources for ascent or lift. But kind of get an idea that maybe it's maxed out at 500 millibars. So again, very strongly forced system, mainly to the north and west of central Oklahoma is what it looks like at this time. Just another thing that I want to emphasize as well, just a negatively tilted trough. So that really just means that you're gaining kinetic energy from the background environment. It's what we call barotropic energy conversion, that negatively tilted trough there. So just a very favorable synoptic setup. And in response to this synoptic scale forcing for ascent, also very impressive low-level dynamics as well as thermodynamics. Really strong low-level flow, so you're going to get very strong moisture advection, moisture return from the Gulf and the Caribbean, things like that. And really all these ingredients coming together will produce a very volatile environment across much of Oklahoma, at least the western half of Oklahoma, and into Texas, the western portions of Texas into the Panhandle, and maybe just south of the Red River near Childress, Wichita Falls, that area as well. So looking a little bit lower now, this is 850 millibars, so maybe somewhat of a kind of somewhere where you'd expect to see a low-level jet. So this is an extremely synoptically forced low-level jet. So this is 0Z Tuesday. I mean, 50 knot low-level flow, 50 knot 850 millibar flow over central Oklahoma. So that's really just going to continuously bring in moisture from the south. We saw how rich that moisture is down in places like Corpus Christi. And it will also increase the low-level shear. So that will lengthen your hodographs. You consider things like streamwise vorticity, storm relative helicity. This low-level flow will greatly enhance your streamwise vorticity. And then into the evening hours, I mean, this is the strongest synoptically forced low-level jet I've seen really ever in this late in the season. In my experience, that's 80 knots. So just very, very strong flow across central Oklahoma into central Texas as well. So let's just kind of show, again, not going to worry about exact placement of the boundary. Models have had some issues kind of resolving where this boundary is going to eventually stall out. But you can see by early morning, really this that stationary front surges along the Red River. That'll eventually continue to lift north. But look at all that rich moisture, dew points in the low to even mid 70s across central Oklahoma. And then eventually where this boundary stalls out, that'll probably be one focal point for severe storms. And there's that dry line across the Texas Panhandle into the afternoon and evening hours. Dry line placement, I would actually place it a little bit further west considering how much moisture this region has seen. So far, just a lot of soil moisture, so that tends to mean a lot of evapotranspiration and just evaporation of soil moisture, and that might delay the eastward mixing or the diurnal mixing of this dry line further east. So I'd actually probably place this dry line a little bit further to the west. In terms of the storm mode, convective mode rather, these are effective bulk wind difference. So these are your deep layer shear vectors within the effective the layer. And you can see relative to the dry line, shear vectors are oriented roughly perpendicular to the dry line. So that would definitely favor a more discrete mode. Further more north, closer to the triple point across the kind of northeastern Texas Panhandle, I guess Spearman, Perryton, that kind of area right there. Shear vectors are located, or they're oriented roughly, or more or less perpendicular to the boundary, but slightly less than 90 degrees, maybe about 45 degrees. That's actually probably a better description of it. So as we talked about earlier, the synoptic scale of forcing for ascent is a little bit stronger further north across Texas and Oklahoma, northwestern Oklahoma into the northern Texas panhandle, and the shear vectors maybe not quite as perpendicular relative to the stationary front. So maybe up there we'd expect more of a mixed mode, cluster mode, kind of more storm interactions. Um, and then across really central Oklahoma, shear vectors, again, pretty large angle relative to the stationary front, especially across western and central Oklahoma. So that would favor more of a discrete mode. Further east, shear vectors are kind of oriented parallel to the boundary. So that really would just mean a lot of stuff, a lot of storm interactions, kind of a multicellular mode. And that really brings up the issue for training supercells, flooding. I think flooding is really going to be a big issue with just tomorrow in general across the region. Let's pull up the sounding. Again, this is just in the warm sector, so I just chose Norman. I mean, really not much wrong with that sounding. We're uncapped, and the fact that we're actually uncapped really through a large portion of tomorrow. Really not much cap past 18Z. So storms might get going pretty early. There might be multiple rounds of convection. And this is what some convection allowing models have been showing too. But really it won't take long for the atmosphere to recover, given that really strong, sustained 850 millibar flow, continuously bringing in rich moisture from the south, really helping with that destabilization as well. In terms of just the flooding threat, these are the total precipitable water. These are standardized anomalies, and you can see values exceeding 2 to 3 standard deviations above climatology over the region. So talking, yeah, almost 99th percentile at this point. So flooding is definitely going to be an issue, especially with any training storms. Storms should be very much capable of producing very heavy rain, especially when you get training supercells. And if storms manage to kind of stay in that localized zone of ascent, along the boundaries, so the stationary front, for example, that really could be an issue where that stationary front stalls out. That really will probably be where the greatest flooding threat will occur. So kind of, yeah, let's just pull up a sounding. Let's pull up another sounding, maybe earlier in the day, a little bit further west. So I don't know, let's go to Childress. Looks like there's actually some convective feedback there. Yeah, that's a convectively contaminated sounding. So let's go a little bit earlier in the day. Yeah. So yeah, again, this is just a very, that's not the best looking. Let's go a little bit deeper in the warm sector. Yeah, that is a strong clockwise curvature in the photographs. So this would indicate primarily streamwise vorticity. Storm relative felicity is very, very favorable, especially within the effective inflow layer. So what the storm is actually ingesting. So this is obviously very, very much unfavorable for tornadoes, potentially strong, especially if storms can remain discrete and really limiting interactions with each other. So that's really all I wanted to talk about today. Again, these were my views alone. Always happy to hear any constructive feedback, comments, criticism, or just discussion in general. So thank you for watching. Everyone, please be safe tomorrow. And if you don't already have a plan in place, and please stay tuned to your local Weather Service office, Storm Prediction Center. Again, these folks are the best in the business. So be safe.